Theorem 4.6, the first derivative test. Let C be a critical number of a function f that is continuous on an open interval I containing C. If f is differentiable on the interval, except possibly at C, then f of C can be classified as follows. 1. If the derivative of f of x changes from negative to positive at C, then f has a relative minimum at C, comma, f of C. Number 2, if the derivative of f of x changes from positive to negative at C, then f has a relative maximum at C, f of C. If the derivative of f of x is positive on both sides or negative on both sides, then f of C is neither a relative min or maximum. So let's look at these diagrams down here to illustrate what these three possibilities for the derivative test is trying to illustrate. So the first one, right here, where the derivative, which is just the slope, is changing from negative to positive at C. Okay, here the slope is negative, there the slope is positive. It changes at C, so at C you would have a relative minimum. Number 2, the slope, remember, the derivative of f of x is just a way of saying the slope. It changes from positive to negative, so here it's positive, there it's negative. It changes at C. Here you'd have a relative max. And then condition 3, if both sides are positive, so here the slope is positive, there is the C, and then on this side it's also positive, so that would not be a relative min or max. Over here it's both negative. So let's look at an example how we could apply the first derivative test. Find the relative extrema of the function 1/2 x minus sine x in the interval from 0 to 2 pi, the open interval. Okay, so we want to find the relative extrema, the relative mins and max. We're going to do that by using the first derivative test. Okay, this graph, you wouldn't be given this graph on a test, but this would be the relative min, this would be the relative max. Here you can see that the function is decreasing, and then at C it switches, and then it's increasing, and then at another C value it's decreasing again. So at these points here, these are the relative extremas. We're going to use the first derivative test to find those points. So always find the domain of the function first. So if you look at this function, the domain of 1/2 of x, that would be all reals. The domain of sine of x, that would be all reals. So the domain of this function would have to be all reals. Okay, next we're going to take the derivative of the function, and it's going to be 1/2 minus cosine of x okay, and C are the critical numbers, so we got to find the critical numbers. So to find the critical numbers, we take the derivative, set it equal to 0. We also want to find the x values that would make the derivative not exist. Nothing, that would not happen here because all x values exist for the cosine of x here. Basically, we don't have a variable in the denominator anywhere, so we're good. Okay, so let's see, this would be cosine of x equals 1/2. Now we got to find the angle x or cosine of x that is equal to 1/2. So this is equal to adjacent over the hypotenuse. So we're going to use Pythagorean Theorem. So the adjacent side is 1, so 1 squared is 1. Y squared, we don't know. That would be the opposite side. And the hypotenuse is 2, so that's going to be 4. So y squared would equal 3. Y equals plus or minus the square root of 3. So now if we drew this on the coordinate plane system, where the adjacent side is 1, so this side is 1. The opposite side is either the square root of 3 or negative square roots of 3, and the hypotenuse is 2. Now this triangle isn't drawn to scale, it's just to give us an idea. And in here, this is the measure of angle x, and right here, we have to find both of those. So first of all, I'm going to make this the unit circle by dividing all of these by 2. Then this triangle should look really familiar to you, where this is a 30, 60, 90 triangle, where this x here would be 60 degrees or pi over 6. Okay? And then to find this angle, well, we know that all the way around here, that would be 2 pi. And then if you would subtract this angle here, which is pi over 6, oh, that should be pi over 3, sorry. Pi over 3. Let's see, this is going to be 12 over, what's that? It's going to be 6 over 3, which would be 5 pi over 3. That's going to be the other x. So now we know x is equal to pi over 3, and x is also equal to 5 pi over 3. That's going to be these points here, but we have to show that one of these is a relative min, one is a relative max, using calculus. So we know that on the open interval here that we're looking at, it's from 0 to 2 pi. We know that we have one of the critical values at pi thirds. The other critical value is 5 pi thirds. So we have the interval from 0 to pi thirds, another interval 3 or pi over 3 and 5 pi over 3, and another interval 5 pi thirds to 2 pi. So we need to test each of these intervals. So here, let's see, a point between 0 and pi over 3 would be pi fourths. Okay. Let's see, between pi thirds and 5 pi over 3, let's test pi halves. And here, let's see, since that's right here, that is 60 degrees. So if we cut a triangle that's 30 degrees, that's going to be in between 5 pi thirds and 2 pi. So let's do 2 pi minus pi over 6, which would be 12 pi over 6 minus pi over 6, which would be 11 pi over 6. So here we'll test 11 pi over 6. Alright. So now we got to test all of these into here. Okay, so let's test 1/2 minus cosine of pi fourths. So that's going to be 1/2 minus the square root of 2 over 2. Okay, we know that that is going to be negative because the square root of 2 over 2 is slightly bigger than 1/2. So for this region here, it's going to be the derivative of f of x is going to be less than 0. Let's try the next one. So now let's test 1/2 minus cosine pi halves. Cosine of pi halves is 0, so that's going to be 1/2 minus 0, so that's going to be positive. So here it's going to be f prime of x is greater than 0. The last one is 11 pi over 6. That would be this one here. So, okay, so now we need to do 1/2 minus cosine of 11 pi over 6. Okay, so 11 pi over 6 is really this triangle here. Okay, where that's like a 30 degree. So this would be 1/2. Okay, that would be 1. That can't be right. So that would be 1/2, negative 1/2. This would be square root of 3 over 2. So, let's see. We know that cosine of that angle would be opposite over adjacent, so negative 1/2. So this would be 1/2 minus negative 1/2, which would be positive 1. So this one would be f prime of x is greater than 0. Okay, so this interval here, this first interval, the derivative is less than, so it's the slope is decreasing. Here the derivative is positive, so the slope is increasing. Here the slope, let's see, I messed this last one up. This shouldn't be negative 1/2 because cosine is adjacent. So the adjacent side is actually the square root of 3 over 2. So this would be negative. So here the derivative of f of x is going to be less than 0, so that's going to decrease. So at this point here, this is going to be a relative min. Here you're going to have a relative max. This would be your min, this would be your max.